I would like to thank MITRE Ingenuity for organizing this exciting panel. Can we go to the next slide, please? There was one on the panelists. Before we go to the panel discussion, I would like to have a quick round of introductions. We have an exciting panel today with four experts in the smart agriculture domain. Let me introduce myself very quickly. I'm a professor at NC State University, and I'm also the director for the NSF AirPower platform, which is a wireless testbed platform for doing experiments with advanced wireless and drones. I would like to go around first. Okay, let me go through the first two slides. I want to have this panel in two different segments. In the first segment, I would like to talk about a bit about the uses of machine learning and 5G in the smart agriculture domain. I picked this image from one of the recent publications from last year from Elsevier. This basically shows use cases of 5G in various different possible applications of smart agriculture. You can see farm vehicles, you can see drones, and collecting data from sensors. So some of these use cases may require very high data rates, some others may require low latency for control, or some others may require support for a large number of sensors with long operational time. Next slide, please. And this is yet another image and a table from a recently published paper from earlier this year related to uses of AI and ML techniques for smart agriculture. For this particular example, you can see that such techniques may be used at the physical layer, edge layer, and the cloud layer. There can be AI ML techniques to control vehicles or wireless technology, or at the edge layer and the cloud layer. There may also be various different applications. And you can also see on the table on the right, there may be uses for soil type prediction, prediction of the yield, classification of various different things with ML techniques. Just to set the background basic, because there are various different use cases of AI and ML techniques, and I would like to talk about first the 5G and AI ML specifically for the smart agriculture. We can go to the next slide and we can start with some initial panel discussion. So let's go around the panel first and have a quick round of introductions. Dez, maybe we start with yourself.
Yeah, hi everyone. My name's Dez O'Connor. I'm from Cisco. I live in London. And I'm here to talk to you today about some of the projects that I've run over here in the United Kingdom around connecting 5G in very rural communities. In fact, some of the most rural communities in the whole of this country, the Orkney Islands, where there's very little broadband, but lots of opportunity and willingness. So yeah, I'm responsible for developing our private 5G solutions at Cisco with my other hat on. And thank you for having me.
Thank you, Dez. Abhilash?
Hi, everyone. This is Abhilash Chandel from Virginia Tech. I'm an assistant professor for Precision Ag Technologies and Data Management here. I work mostly with crop monitoring and management, and I use technologies based on satellites, based on drones, and some of the in-field installed sensors like weather sensors, soil moisture sensors, and derive decisions based on machine learning or biophysical models for ultimate crop management. Thank you.
Thank you. Mike?
Yeah, thanks so much, Ismail. Mike Prorock, founder, CTO over at Measure.io. We tend to be working more on the machine learning side, though, in just vast amounts of data from a variety of different sensor stuff, ranging from the trade side and cross-border shipments to out in the field and confirming predictions when we're predicting for things like soil moisture or soil conditions. So,
thank you, Mike. Tony?
Hello, thanks for having me participate on the panel today. My name is Tony Sammarco. I'm Director of Technology Strategy at Device Solutions and have a little over 30 years of experience with wireless and cellular development and IoT product design for agriculture. Device Solutions were strategically located in RTP, North Carolina, close to NC State and some world-class universities and companies that support the wireless industry with tremendous engineering innovation towards ag solutions. And I'm responsible for driving technology partnerships for IoT ag products and have enjoyed watching the industry come together to support IoT for ag through standardization and really creative network evolution and really creative engineering. So thanks for having me on the panel.
Thank you, Tony. First, I would like to start with your views on use cases of 5G. So as I've shown in the earlier slide, as you all know, there are three primary features of 5G. So it can support very high data rates, which we call mobile broadband. It can support large number of sensors, massive machine type communications, and it can also support low latency, ultra reliable low latency communications. Right? Those are all advertised as key use cases of key features of 5G. So I'm curious about your views on how which of those features are more critical for smart agriculture domain, and whether you use any of these features in your companies and in your at your university. Maybe we can start with Abhilash.
Yeah, sure. Thank you, Ismail. So as far as I look at enhanced mobile broadband, of course, it does offer a lot of a greater bandwidth with a good improvement over latency. So what I feel the applications could be related to mostly monitoring of the crops and the soil environment systems. For example, if you want to gather information about soil moisture, soil climate, soil pH, soil electrical conductivity, which is the major influences of the soil climate that supports crop growth, that may be one aspect of monitoring. The second aspect could be monitoring of the open field weather, like relative humidity, air temperature, rainfall, precipitation, lightning strikes, and then kind of having some level of platform capability in modeling out the decisions based on these data. So these data sizes are not like large enough, but can still provide a lot of improvement in decisions. For example, if a grower wants to predict what is the risk of onset of a freezing event so that he can plan about his crop harvest or crop management or taking the crop from his field to his storage facility. And that is kind of decision that can, I think, be supported by enhanced mobile broadband services. When it comes to massive machine type communication, which we call MMTC, it is a slightly more advanced version and also offers the IoT Internet of Things capability. Now coming to that, and also then going back to ultra reliable low latency and much more bandwidth compared to all of the three, it's really the case by case basis. Now I would like to summarize based on the types of applications. So if we talk about the drone imagery data collection, so starting from the image collection to acquisition to data handling to management to analysis to decision generation and implementation, this is a whole lot of data that goes into processing. Now, ultra reliable low latency and more bandwidth can be like a good avenue for these kind of data processes. And when we talk about URLLC, for some of the applications that requires quick treatment or quick action, rapid action. For example, if there is a field infestation by deers, if there's a field infestation by groundhogs, if there is something wrong decision happening on the field, like wrong time irrigation, it has to be immediately cut off. You don't want a latency in that kind of decision making. So these kind of or ultra reliable low latency and more bandwidth, this kind of 5G connectivity can really help in that side, whereas the enhanced mobile broadband can really focus on the decisions that could be implemented at the like a 1 day interval or 2 day interval after monitoring or mapping. So that's what my submission would be, but it's always on the case by case basis, the volumes of data, the volumes of analysis that needs to be carried on.
Thank you very much. Dez, would you have any views? I know Cisco has a lot of work with 5G, and you have also a lot of related background.
Yes, I think in general, I would say we did a lot of use cases up in the Orkney Islands and around the UK over a couple of years for many rural agritech use cases, right from salmon fishing to tractor drone kind of combinations doing automatic feeding and fertilizing, etc. Transport, many, and 95% of the time, EMBB, high speed, particularly on the uplink, was the most important requirement. There was only really one use case, and it was the tractor drone combination for crop dusting, where I did find a low latency requirement, and that was specifically because we had the AI in the cloud. We had a load of cameras on a drone flying in front of the crop duster, and then we had a bunch more cameras on the tractor itself with the actuators, etc. And we found that because of the images were coming from the drone to the AI in the cloud, and then that had to be correlated with the cameras from the tractor, and then actuate and actually set it to do precision spraying on exactly the right piece of crop or weed. What we found that where we had the user plane, this is the 5G terminology, the user plane was up in Edinburgh in Scotland, and the farm was down in Shropshire in the middle of England. So it's not a big country, but big enough actually. We slowed the use case down by 50% when I moved that user plane locally and reduced the latency to something like 10 milliseconds. I sped up the whole process by about a factor of 2.
Thank you very much. Do any of you see using 5G can help basically for a good return of investment in the smart agriculture domain? Maybe Tony, I guess you have some work in your company related to this.
Yeah, I mean, precision architecture is such a hot buzzword, and really second only to ROI in my world. For 5G, it's really cost and connectivity for our smart farm solutions. And there are so many components that contribute to achieving precision architecture and good ROI. And it really started in earnest back with 4G and now 5G as we move to cheaper IoT modules and monthly subscriptions that have driven costs down enough to really open the doors for a much broader spectrum of connected agriculture, similar to the evolutionary path of smart cities. So the 5G offering of higher speed, lower latency, greater capacity than 4G has enabled so many more connected devices at the farm to give a more complete picture. So at a basic level, it's coverage, just plain getting connected. And so many farms were remote and didn't even have Ethernet backhaul. So why is this important to ROI? Being able to cost effectively add more sensors helps create this much bigger, complete picture of analytics that can contribute to so many other parts of the ecosystem than just the individual grower at the farm. So the connected nodes, we also found in our deployments of tens of thousands of farms with bins for monitoring grain bin feed levels. I'll talk more about that in a little bit, but the more processing at the edge that the power gives us with the 5G modules. So we actually have more processing power to do more computing at the local site than having to have a mesh network to aggregate all this data and provide more data up to the cloud for computing. We can actually be a lot smarter at the edge. And more importantly, kind of to wrap up this little bit of discussion here, is that all the other parts of the ecosystem, not just the grower, but the mills, the producers, the farm tech companies that provide a complete solution for managing the smart farm can be had.
Thank you very much, Tony. So you talked about AI and ML. Let's discuss about that a bit more. So there are many different ways that one can use AI and ML techniques. In the example image I shown earlier, you can use them at the physical layer of the network or for controlling drones with some smart basic trajectories, or you can use it at the edge or at the cloud, right? There are many different use cases. So in your opinion, what are the key killer applications for AI and ML? And if you are using those in your work, can you give some examples? Maybe we'll go with Mike this time. I know.
Yeah, happy to. And yeah, that is kind of the world we tend to live in. And, I'm probably a bit of the naysayer on the group from like a 5G and rolling devices out everywhere across, all farms. I mean, there are certainly use cases for that, but I think the reality that we found in practice is that you need ML to fill the gaps, right? There's just so much land space that we're looking at that you'll never deploy devices everywhere that it's needed. The feed bin example that Tony brought up is an excellent one, right? And I think I'm actually pretty familiar with that one. If it's the feeding of hogs and knowing when to get trains rolling I know that case extremely well, and those guys down there working on that. And so there are cases like that where it makes sense to go instrument every aspect of a particular, vertically integrated operation. But when you go start looking at like some of the stuff we're looking at with like avocados out in the middle of Peru and stuff like that, it's just not going to happen. And so if you can't go in and validate the predictions that you're making with machine learning to say, oh yeah, we're expecting leaf wetness to be high on a certain day and a certain amount of evapotranspiration, not being where it needs to be, and you're getting fungal pathogen, foliar pathogens, popping up and causing a problem with the crop. That's what ML can tell you, right? Is what actions do you need to be taking when independent of having a device there. And 5G is actually how you can go in and get the validation data that you need to know if stuff is drifting, or are you seeing a different behavior, sometimes even down at the subspecies level, right? There are certain pathogens, for instance, that we're predicting for where one particular variant, say like Fusarium, right, behaves very, very differently. Depending on the environmental conditions, depending on the exact subspecies and the, traits we're seeing going on within that pathogen. And so being able to actually validate that quickly from the field is really key. Even sometimes the stuff we're seeing with like spore data collection, right? And how quickly can you cycle PCR, qPCR results back into models to retrain and then update. Like we just had a piece of information come in from Japan 2 days ago on a certain foliar pathogen. That was cycled back out into the field and making predictions on site across Japan based on one additional data point that then corrected for a change in environmental conditions that wasn't expected. So those are the kinds of shortening of loops that we could see with ML that are being enabled by 5G, which is awesome in my mind.
Thanks so much. Great comments. Any other comments related to use of AI ML in precision agriculture?
Sure, thanks. I would like to point out two key applications that we have been working on. So one is using the edge computation systems, using single board computers to monitor the fruit surface temperature in apples. And that was a project set up in Washington State, and that was about monitoring the susceptibility of sunburn, because fresh market apples, having those carried until the selling stores is a big challenge, and most of the fruits are getting lost to sunburn due to excessive temperature rises. So what we did, we had this integrated thermal and RGB camera sensing node, and we also had a weather sensing node in grower fields. Now, as my fellow panelists mentioned, that we cannot have these fixed sensors all over in the entire field. So we wanted to also have a generalistic model. And then using the machine learning and image analysis, we just extracted the fruit surface temperature. And based on when it reached the threshold about over 45 degrees Celsius, we immediately pushed an action to actuate the overhead cooling system so that the microclimate cools down. And we used a localized, the edge-based internet connectivity. And then, of course, we were not having 5G connectivity there, but now there is. So we are trying to use that as a platform to have monitoring of the decisions, whatever is happening, but there's a minimum dependency from the user side. So the models by our group have been now well validated and are now being implemented on the grower's side. The second case study, what I would like to mention, is about mapping evapotranspiration, nothing but the crop water use. And this I did using the small unmanned aerial systems or drones, using thermal and multispectral images. The most important key area is it might not have an ML application or may have, but there is already an existing biophysical models which are like highly validated all over the world, which are more trustworthy, what I would say, compared to ML. If there is a constraint about validating, I would always go for a biophysical model. Now, we of course did like in-house processing to generate the maps. Now the gap is collecting that data or parsing that data from the drone itself and stitching it. That's one of the biggest challenge, real-time stitching of the data. Some companies do offer stitching, but it's low resolution. It's just for visual interpretations. So that is one of the gap that we are trying to explore and try to solve, which could be really groundbreaking when it comes to irrigation management at the real grower end. And also, I would like to add one more case study where we were using a 5G connectivity from a company called Open Innovation Lab in Washington State, where we had all the tons of sensors installed in a cropping system. It was having soil moisture sensor, it has soil nutrient sensors, nitrogen, phosphorus, potassium, leaf wetness sensor, weather sensor, and all that data we kind of demonstrated to the stakeholders how that can get collected to promote its adaptability as well. So that was one of the thing. And then we regulated decisions of irrigation management. Of course, that was mostly on temporal basis based on the weather data, but there's a gap on integrating the spatial aspect that drones can capture and then the temporal aspect that weather can provide you. So
I was going to jump in because we've been talking a lot about the AI, ML, things like that. I'm not a big AI term fan, but for a variety of reasons, but like machine learning, especially at the field level, right? And that's a valid, awesome use case. What's been interesting for me is, especially over the last, 18 months with COVID, seeing these intersection of the field data back with the broader OSINT data coming in from the trade side with ship positioning, with things like that. In case in point, when Ukraine started, right, we suddenly just got swarmed with all sorts of customer activity that we weren't expecting. To come out in the way that it did, just to understand what was going on with rail lines and what was going to be affected across ag in general, right? With very large scale procurement changes having to occur. Like, hey, all of a sudden we've got to reroute wheat purchasing or potash purchasing or whatever it was, throughout very large, vertical supply chains. These are the things we're getting that connectivity out in the field. That's one piece of the information that's required, like what's not ready for harvest yet, what can't be harvested yet because we've got mines out in the field and can't get a tractor on it. But being able to link all that data together has been really key for us, and has been really key for a lot of, when we look at how the food ultimately gets to the consumer, right, that's where that meets, right? And so with those supply chain interruptions, this actually all this data we're talking about at the field level carries all the way down to that level, and it's something we shouldn't forget about.
Thanks a lot, Mike. Do you see any connections between 5G and collecting AI data for AI ML techniques more efficiently for maybe improving cost efficiency, improving operations, and reducing costs? So are 5G and AI ML, are they connected? Can 5G help reducing the cost? And maybe again to your ROI comments, Tony, you had earlier.
Sure. And similar to what Mike was saying, we tend to take the term maybe as he does for AI, for machine learning for us, we like to think of machine learning as ecosystem learning. So we're not just focused on a single point within the ecosystem. It's the entire ecosystem that can learn from all this data collectively being analyzed in a smart way. So what started for us as a very innovative, very cheap, very easily retrofitted sensor in small grain bins to help predict feed level in the bins as a very localized benefit for the individual grower. It's a time saver. They don't have to climb bins. They don't have to look down in bins. They ensuring that the hogs don't run out of feed, that they can order more at the mill. That then turned into the mills got very excited about understanding route optimization of delivery of grain, about grain ordering and forecasting of grain. Do they need to get more grain from other sources that they need to have brought in? They can do some really smart predictive analytics based on weather, based on consumption, based on eggs, et cetera, based on age of the growers' crops. Move around the ecosystem even further to the farm services solution folks, where they can marry this data with all the other farm services that they offer with respect to water, medicine, all the other components of a smart farm that are required by the regulatory bodies, and then move that all the way to the big producers like the Smithfields and the Purdue's of the world for predicting when crops are at their peak for harvesting, for example. So what started as a simple connected, with the 5G enablement of connected sensors, to come into an ecosystem learning perspective to bring about an ROI that benefits the entire ecosystem, not just the grower.
And then we will continue the connections between 5G and AI/ML. Can I bring back the slides, if possible? Yeah, thank you. So another technology that is commonly referred for use cases in smart agriculture is, as we all know, is drones. And this image is from yet another paper that's published earlier this year in IoT magazine. It talks about many different challenges of using drones for smart agriculture, like connectivity between the drones if you have a swarm of drones, and connectivity problems between the drones and the ground infrastructure, and the maintenance cost and installation costs to support drones, privacy challenges, flying permissions with FAA, the safety concerns, and positioning and localization. So drones, as was also mentioned in Paul's talk earlier from Ericsson, the keynote talk, they can significantly increase, for example, seed basically deployment and many other use cases as well. But there are also these challenges. Next slide, please. And looking at a more general perspective, there are also many regulatory challenges around smart agriculture. I picked this list. It's a subset of the regulatory issues from EPA's website. There are regulations related to livestock, lands, farm facilities, oil storage, and we all know about FAA regulations for flying drones, difficulties for having beyond visual line of sight type of flights. And there are also some ACC regulations related to the use of the spectrum. And Paul also gave some examples on potential cost savings from precision agriculture technologies. This is yet another example from that I found online related to savings in yield and GPS and other technologies, how they can result in savings in costs for smart agriculture. So let's also keep this in perspective and connect this, if you can, with the 5G and AI/ML. We can go back to the panel discussion. Stop sharing. Yeah. So I'm curious now about your views on key applications of drones in smart agriculture. And if you see any challenges, I mean, there were also a list of challenges earlier, especially from maybe communications point of view or AI/ML, data collection, and why do they matter? And what is the key use case for drones and why they are important? Anyone wants to take a shot first?
I can dive right in. I mean, one of the problems I think with imagery in general, right, or sensors in general, right, is that it's inherently in the past, right? It's either now at the moment or it's in the past. And so when we look at lowering latency, which is what 5G is getting us, is a more pipe and the ability to operate on this information quicker. When we think about using drones for scouting, right, think about a couple of sections of farmland, you got to go out and, I guess, context for non-farmers, 640 acres several times over, right, is a lot of the operations we're looking at. Being able to actually know where to go deploy resources by combining ML, right, in pretty near real time to identify, say, hey, is there an actual pest or a threat that we need to actually take action on, right, immediately? Think about cattle operations and interruptions on fencing, right? If you've never chased cattle down out of the side of an interstate, you should sometime. It's an experience. So knowing if that, knowing if you got a fence break immediately, yeah, it's pretty critical, right? And so these are things that we need to be thinking about that are getting enabled by actual scouting via, getting this information, close to immediately potentially, as opposed to sitting a week in practice, right, and waiting for this data to come back and get analyzed and processed.
Well, I would like to add a few things in there. And there was also a question from audience, what impact of 5G what has the maximum impact on agriculture from the 5G perspective. I would say the broadband, the bandwidth, and the latency reduction. That's one of the key areas when we want to implement some of the quick remedial actions for crop management. I think 5G offers that. So that is one of the area that we would all definitely want to bank on. The one of the sorry.
I'll add one other thing to that actually as well. I would say actually, even though it's not actually a key tenet of 5G, in the 5G era, in many places around the world, spectrum has been liberalized. Mm-hmm. And the big problem with most rural areas is there's a potential to put down a lot of spectrum, but nobody's putting it there. So by liberalizing the spectrum and allowing it to be locally deployed by other entities in the value chain, other than traditional service providers, that has actually provided some significant possibilities as well.
Correct. Yeah. I would just like to add to the case study scenario on the drone data and AI processing. So we have this 5G connectivity and we have these advantages. Now there's a lack of, or what the gap we are suffering right now is the lack of the entire processing pipeline, right from the data collection from the drones, and then how that is pushed to the cloud where it is staged and then processed through AI and machine learning, and you get the decision or implementation map in real time, at least if not in real time. So there's a need for this entire pipeline, which one of the component we are trying to work, because we are trying to go step by step. The first idea is to push that data directly to the cloud from the on-site location, and that needs good amount of latency reduction and the broadband connection. So 5G definitely offers that thing, and we are working on it to get this data pushed to the cloud, and how we can develop custom algorithms, whether be it biophysical models or AI ML models, and then retrieve the information for quick remedial actions, say.
So related to use of drones, what do you see as the most critical challenge for wide-scale adoption, for example, by farmers? What would be needed for farmers to use, or in smart agriculture domain in general?
Yeah, I think let me take that first, because I also have like an extension appointment, so I meet a lot of growers. They're always interested in the cool stuff, in some of the things that can give them information. But it's not only about the end result, it's all about the process that they feel they will have to go through. For example, when we talk about the drones, and if we have to have a capable drone, I would say, not just a consumer grade drone, but a capable drone that can do multifunctional attributes like multispectral camera, thermal imaging camera, LiDAR sensors to measure crop height, terrain mapping or soil mapping. The overall cost of a drone is not less than $100,000 if I have to add this perspective. Now, if I have to add the hyperspectral camera, the cost will again add to $300,000. So giving this aspect, the major feedback that I received, and my major what I came across, is that not all the growers will be able to afford drone. And even if some growers buy drones, there's again a caveat or a catch to it. They might not have sufficient skill set for collecting data, handling data, analyzing data, and moving up to the end point of decision making and implementation. Service providers do have an opportunity to come in there. They do fly drones. They provide those crop insights and DVI maps, for example, some of the fertilizer recommendations, some of the water stress index maps. But imagine a scenario that there's an area that needs to be imaged at a very regular intervals, or at a higher frequency. Now that will add to the cost. Now, when we talk about a small scale grower and the large scale grower, the small scale grower will always fall back on adopting that. And so what we need is scale neutral solutions, and something that is robust enough that everyone can adopt, and without thinking about the amount of effort or the cost involved. So the challenge that we need to address is empowering the growers without putting too much burden on them in terms of the cost or the level of groundwork they need to do. Adding one more point to that, there are fields located near the airspaces, restricted airspaces. and we cannot fly the drone at all. So we don't leave these agricultural farms, right? We don't really deprive those farmers of not imaging, not assessing their crops. So we need, or what I would say is then going into the alternatives of low orbital satellites that somewhere down the lane do provide data at comparable resolutions and are still evolving. So those might be the avenue to explore in future.
I mean, honestly, let's be real here. Let's start by trying to get internet at the farm. I mean, for real, like I've got 3 different ISPs right now. And because of 5G, actually, for the first time, thankfully during COVID, I was able to start legitimately trying to work from home. Right. And we have small operation that, basically we can't keep up with anymore because we can't make enough money to justify keep doing it. Let's be very real. Right. I've never met a farmer that has time or money available. Period. End of sentence. So when we're sitting here talking about stuff that costs, I mean, cool, it's great, it's pie in the sky, and eventually we'll get there, right? There is a future there, but we're not going to get it under the current economic models. And so if we can at least start by getting internet out there so people can even get to information that they need or communicate with their agronomist or their extension agent when they need to, that would be a great start, and 5G can open that door, right? And it is right now, like we're watching that happen. So,
yeah, I'd like to add on really quick. So I actually popped in the IM window coverage and connectivity to that same point. And if you consider a rock quarry an agriculture example, we've worked with some drone folks with respect to estimating the amount of quarry that was mined during that instance. And as Michael was alluding to earlier, it's real time, that instance, marrying that data with local sensors on the ground for monitoring the wells around the perimeter of the quarry to monitoring the pumps that are pumping the water. It's the 5G enablement of coverage and connectivity that enable us to marry that drone data with the data on the ground in a fast, quick, and cost-effective way.
I'd also like to add to this point, because I love the fact that we're being really practical here and talking about the real world. In the real world, what sort of spectrum do you think is going to be out there in rural coverage? It's going to be 700 megahertz. That's going to give you a very small amount of bandwidth that is not these gigabit per second speeds that the drone in question will probably need with all these spectral cameras, etc. So that then leads us to say, well, okay, if the service providers aren't going to economically deploy spectrum at the capacity needed in remote rural areas, who is? And the answer is probably going to be, someone else in the value chain, and it will probably be a private 5G network. And then the question is, how do you deploy a really low cost, really simple to use and deploy network? And the answer from us at Cisco is you deploy it as a service in the cloud, in a way that, it's really simple to assemble, to put up, and to kind of move around.
Yeah, that kind of co-op approach to some of this tech. I mean, we're seeing more and more of this in rural areas kind of across the board. And this is definitely a global thing because the connectivity is needed. The need for, like Cisco and some others are kind of playing with, cloud provisioning, simple drop out a couple of things. And then all of a sudden you got some connectivity. That's cool, right? That's going to change people's lives. And this is where this stuff has to start, when we think about it. So
which spectrum bands do you think are most appropriate for connectivity for rural and especially smart agriculture type of technology? So there is TV white space, which is even below 700 megahertz. 700 megahertz, I guess, Dez, you are referring to cellular bands. And there are all those relatively recent bands like CBRS, C-band. Unfortunately, the problem with those bands is you are not even allowed to have airborne transmissions. So like CBRS or 3.7 gigahertz, FCC has restrictions to transmit from a drone. So what are your views on considering also the coverage versus data rate requirements? If you go higher up, you have more bandwidth, but now the coverage becomes lower. So what are your views on spectrum choice?
Personally, for me, I think if it's public macro coverage, what you'll probably see is the low band. What you'll really need is low band plus mid band, at the C band, in other words. However, to make an operator justify that, they're going to need to build something that I kind of call a business layer cake, which means they can't rely on just one use case. They can't rely on the crop dusting alone, or the salmon farm, or the cattle detection, or the security, or the fixed wireless access to the home. They have to build the layer cake of all of these things, and maybe even make it a neutral host network that is operating on behalf of all the service providers, so that reduces the cost even further. So if it's public, then a combination of low and mid would be my guess. If it's private, mid and high band, I would have thought would be more likely. But again, depending on the use case.
Any other views on this? Or maybe broadening the question a bit more. So 5G is one technology. There are other wireless technologies out there like LoRa or other wide area network technologies. Do you see them competing each other, or do they complement each other?
Yeah, I mean, I did some testing with LoRa early, like, and not a small amount of testing, like rolled a lot of devices out in a lot of different scenarios, and especially trying to roll them with in-ground sensors and things like that. And in practice, it just fell apart right off the bat in agricultural stuff. Like it just did it's got use cases for sure. But 5G actually as an approach seems to be working, like for the, and it was bad enough where we dropped back into like 3G, 2G and 3G modems to get better results until the 5G network got deployed. So, and that was, some semi-global testing, right? We're Australia, some Europe stuff, Japan, a lot in the US, and a little bit in Latin America. And so even just trying to add that complexity of, hey, go drop some base stations out, it's not, that's just not practical. So, but I think, from my standpoint, I think, especially when we look at getting the coverage problem solved first, right, and then possibly tackle some of these private network for high value type use cases. Supply chain comes to mind, right, for some of those things, like where you have grain elevators and stuff like that, where you actually need some, higher bandwidth capabilities. Those are the things that, I think this is why 5G will ultimately end up winning, right, and from a network standpoint. And whatever the successor marketing label is we drop on, so.
Yeah, from the backhaul, absolutely. We have been getting a number of questions, and we've actually provided some solutions for not LoRaWAN, but LoRa as a technology for aggregating sensor data to a 5G enabled gateway. So if you separate LoRaWAN from the LoRa physical layer and MAC layer, we get questions for retrofitting existing costly solutions that are in the field today. So taking a 5G module and aggregating that data rather than to a LoRaWAN gateway, but to a 5G cellular gateway, it has a bit of a niche, and we've actually done that. So we've actually aggregated some of the LoRa-enabled sensors by utilizing the MAC layer and the PHY. So it's a niche, but it is a way to get that last mile of existing retrofit existing sensors.
Yeah, Tony, just out of curiosity, because one of the issues we ran into is as soon as you start getting dew on corn, above about 2 feet in height, things start really getting a little scattered.
Yeah, so we actually did some monitoring of cotton bales with cotton ink here in North Carolina. Yep. Once that canopy grows up, LoRa has real difficulty penetrating the canopy. So we've definitely run into some issues with respect for that kind of RF challenge in those environments.
Yeah. I'm glad we're not the only ones that saw bale tags just cease to function.
Yeah. Cotton is really tricky.
Yeah.
Would drones be able to help for scenarios like that? If it's just data collection, you fly a drone and pick the data, and then data mules type of use cases.
I mean, there might be some value there, but honestly, with the way SAT, is getting, I mean, we're doing a lot of composite, like synthetic aperture radar, plus other bands coming in off of other things. I mean, I'm not, there are cases for autonomous, fixed wing assets or, things like that. But we're seeing less and less. I mean, we're getting accurate enough pretty much globally where, and we just rolled something out in, it's some really, really rural Latin America stuff that's 100% being driven by SATCOM. We haven't put a single UAV into the air of any type. So.
Thank you. So we have 5 minutes left. There is one question from the audience. Have you tried HPUE modems in devices for 10 kilometer gains in the uplink? HPUE will provide 33 dBm links. Any of you have experience with that?
Not me, but I think in general, a lot of the issues around, when we've been talking about 5G a lot, and don't forget there's not a lot of 5G standalone user equipment out there at the moment. So when you're making these decisions, you might want to check have you got a modem from HP or otherwise that's capable of connecting to these networks. Sorry, I haven't tested HP.
Yeah. If there are any questions from the audience, feel free to type them in the chat window. In the meantime, I have one last question. There are several different test beds that may be suitable for testing drones or advanced wireless. Open Generation, Mitre, Ingenuity, they have their test beds. You have the power test beds, one of which is at NC State AirPower with drones and advanced wireless. We have software-defined radios, Ericsson and LoRa, and there are others. Virginia Tech has other wireless capabilities, among other universities. So do you see any value for these test beds to test new innovations, maybe for 5G or drones or other technologies? Can academia contribute in some way? How can industry be motivated to use? So what should be the capabilities for such test beds to test new technologies?
I can take that. So absolutely. I mean, having these test beds solves a purpose for a lot of stakeholders, from researchers to the service providers, to the companies, to the end growers. From the researcher point of view, how we look at is we want to use systems and develop models and validate those models. From the industry point of view, they would want to capitalize on that models and make it like an entire pipeline form and deliver it to the end stakeholder. And for the end stakeholder point of view, he wants to see whether the thing is working as we try to sell them, whether the estimates that we make on the crop by crop basis, for example, in agricultural setting, is that valid? And then the quality of service that the company provides through the entire channel, starting from data collection to data handling and management, and until interpretation and implementation. Once this concept is built up, I think it definitely has the possibility of improving the adaptability, and 5G is that glue that will stick all of these. So that's what I think a test bed can really offer to each. I mean, it offers like something for everyone or everything for everyone.
Yeah, and when we think about test beds too, I mean, I think the way they are now, right, from a fixed deploy side, cool, great. That gives us the next 5-10 years of what should we be looking at. On the practical side, I think if we could start looking more at, being able to localize and rapidly spin up test beds in conjunction with field trial sites, whether that's, like monitoring sites for gray leaf rust, right, or something like that. I mean, there's really practical applications we could be tackling in conjunction with, say, USDA ARS and some extension agents and things like that, just by opening that communication to academia. That it's not there, right? You get these tech nerds, sitting there on one side, trying to tell farmers and extension agents what to do. Well, if that communications path isn't there, these test beds won't exist where they need to in order to see if it's actually helpful to ag. Yeah. So.
I'll add on, in our experience, test beds have primarily been focused towards proving the standard, the RF propagation modeling of 5G and the different frequency bands, rather than I've got a field of cotton with a really big canopy with a lot of moisture. So spinning up, using academia test beds for specific use case examples that we are being challenged to provide solutions for is key for us.
Thank you. Any other parting comments? We have just 1 minute left. I don't see any other questions from the audience.
I'm just going to make a note that, like, what was interesting to me about this panel is there's three, almost four of us all kind of in reasonable proximity who aren't talking at all outside of this panel, which I think is just really interesting. So 5G, if nothing else, is making some great connections and drawing together different aspects of agriculture, from the livestock side to, what Dez is doing out in, the rural areas. I mean, there's some really cool stuff. And, seeing that aspect of the connectivity is a big deal. So.
Thank you. Any other parting comments? Maybe let's go around. So, Tony, do you have any parting comments?
No, I think ag is on a similar path to smart cities, where it started with monitoring light bulbs and street lamps, and then look how that whole ecosystem has grown to provide. A smart city is so much more than monitoring light bulbs. Ag is moving in that same direction. It's no longer just providing data for soil samples and temperature and pH. It's growing into an ecosystem support system.
Thank you. Abhilash, you have any parting comments?
Yeah, I mean, as just to summarize, it's of course the ecosystem that can provide us the validating results and trustworthy results. So it's not only the soil side, or it's not only the crop side, or it's not just on the weather side. It's the entire ecosystem: crop plus soil plus weather. And when I talk about 5G is that very important key glue that sticks everything and has the capability to offer analysis and then ultimately change something that we desire of having, maybe in coming time, sustainable crop production. So everything goes hand in hand. There are a lot of moving parts, but synchronizing that, 5G has a good role to play there.
Thanks a lot.
Yeah, for me, I'd say two things. If you're looking at using public 5G networks, look at the capacity and the coverage, make sure you've got it. If you're looking at deploying private 5G networks, look for simplicity.
I'm looking forward to having lunch with this whole panel.
Yes.
Share some time. We are not far.
We'll invite this for, I guess, to US. Once he's here, maybe we can arrange a lunch together.
IETF's coming up in London in November. Maybe take advantage of that.
I'll buy you a beer.
Yep.
Right. It was an exciting panel. Thank you to each of you. I learned a lot myself. We are wrapping up the panel. I guess Maida is going to take over. Thanks for all the awesome comments. Hope to see you again in the close future.
Thank you all.
Thanks all.